In this example, I have the demand for real money balances, which you can see as a Keynesian function. Demand for real money balances not only depends upon our real GDP, but is also inversely related to our nominal interest rates. So in this question, we first have to find an expression for velocity and then calculate velocity given the real interest rate is 4% and my expectation of inflation is 1%. So first, finding for velocity, I know velocity is nominal GDP over m, and I can again take this p in the denominator and it gives me y over m over p, which is my demand for real money balances. Demand for real money balances is already given to us, so substituting that over here, y and y cancel each other out. I squared is my denominator of the denominator, which is essentially the numerator, so I can bring it up on the top. Taking the inverse of 0.001, it gives me 10,000 I squared. And you can see this expression is telling us that velocity directly depends upon interest rate fluctuations. Higher the interest rate, higher will be the velocity. Lower the interest rate, lower will be our velocity. Now let's calculate velocity for this given information. Note over here that the real interest rate is 4% and my expectation of inflation is 1%. This information is asking you to use your understanding of the Fisher equation, which tells you nominal are simply real plus expectation of inflation. In this case, my nominal interest rate is therefore 5%. And remember, we are going to substitute always in terms of decimal points. So 5% is 0.05. Using my velocity function, I get my velocity of money supply as 25, which is quite close to what we actually get for velocity of M1. Velocity of M1 usually ranges anywhere between 10 to 20. In the second question, you're asked what will happen to your nominal GDP if money supply grows by 20%, but velocity is declining by 30%. So recall our dynamic form of the equation of exchange. These are all percentage changes. For nominal GDP, I can write this as percentage change in p times y. And this tells me that my nominal GDP will actually decline by 10%. And this is a very interesting outcome, and you can apply it to the real world situation. Imagine a situation in which your central bank is injecting huge amounts of money into this financial system by conducting large quantitative easing programs. So they are increasing the monetary base, causing the money supply to increase, and it's in fact increasing by 20%. However, if people are not spending that money, or if financial institutions are not spending that money that is being injected into the financial system, then velocity is actually declining, and in this case it is declining by 30%. So when people fear the future, being apprehensive about the future, they don't want to spend too much, they are hoarding on to all of that additional cash that they have, they are not using that cash for additional transactions. Number of transactions on average have drastically gone down, and all of this new money being pumped in the economy has no effect, but in fact the declining velocity offsets the effect of this increased money supply, and our nominal GDP actually decreases by 10%. We saw this in the aftermath of the financial crisis. The US Federal Reserve injected huge amounts of money into the financial system. However, the nominal GDP was still declined, and if we look at data for that time period, it also shows us that velocity was actually declined. So velocity, remember, depends upon people's behavior, and people's behavior cannot always be predicted. So if people are holding on to their money and not using it for transactions, velocity is declining, and we are not having our desired effect on the economy through this monetary expansion. So this was a very simple example of when your money demand is unstable, velocity is not constant, quantity theory of money is completely ineffective. It does not help us control nominal GDP or the inflation in this economy.